Greetings, everyone. My name is Marcelo. I'm the head of infrastructure modernization at Mechanical Rock. And today we have the pleasure of talking with Paul, also from Mechanical Rock, who's the head of data. Introduce yourself, Paul.
Hi, I'm Paul. I'm the head of data, like Marcelo said. We're interested in all things data movement, data engineering, data processing, and the rest. And yeah, I'm really looking forward to talking about Kinesis and streaming.
So if you haven't heard, it is data month, right? September is data month for Mechanical Rock. So today's topic of discussion will be streaming 101, streaming data, I guess with more of a focus on in AWS and how we can get around streaming data. So I'm going to share some screens of my slides and we'll walk through what streaming is and how we can apply some analytics in real time or near real time. And we'll finish off with an example of how we can apply that newfound knowledge we have with streaming data and managing streams. So I'll share my screen now. All right, Paul, what can you see on your screen?
Nothing.
Nothing. That's because I haven't clicked the button yet. Yeah. Let me click that button.
It's a good test.
see if you're awake. Yeah, okay, and tuned in. All right, so what can you see now?
Streaming 101. This sounds interesting.
And it has never been easier to build your own streaming application with some near real-time analytics. So now every guy and his dog should be able to do so after going through this. And all right, here we go. All right, so what is streaming data? Streaming data, well, it's basically data that is continuously generated by various data sources. So streaming data is also known as unbounded data. So data that has no start or finish, I guess, no start or finish, pretty much. So basically a source that's generating data continuously to some endpoint that, that you want to capture, view, analyze, or do whatever you want with it. So, and some of those sources can be, system generating logs continuously, gaming generating statistics, financial transactions like the stock exchange, IoT devices for telemetry data for monitoring systems, temperatures, oil pressures, all that kind of stuff that are continually sending data in an unbounded context. So what's your exposure to streaming data, Paul?
So yeah, we've obviously done a few projects with Kinesis and a few of its different incarnations, as well as other streaming products like Kafka, for example. And it's interesting to compare the use cases that people choose streaming for, because a lot of people, when they're talking about data processing, are working in batch. So streaming is obviously a different use case. And sometimes people get them mixed up or try to solve different problems with similar solutions. And really, if you look at different cloud solutions, you see they all have different offerings for streaming solutions. So it's obviously an important differentiation to make.
Yeah, so today what we have here is like for Amazon, AWS, Amazon Kinesis platform. So I guess there's three main categories they have for streaming data continuously, and that's the Kinesis data streams, Kinesis Firehose, and Kinesis video. So Kinesis data streams is probably your, I guess, is basically consisting of having a producer producing data from either on the cloud somewhere or the web somewhere or an IoT device, and which is then transmitting all that data to what AWS defines as a stream in the cloud, which then consumers can consume that data from for whatever purpose they want. So that you end up with an endpoint that's continuously capturing data and buffering to whatever your requirements are. So, and it just sits there. So that's all that Kinesis data streams do. And it's up to you to then consume that and process it or persist it. Whereas then you got Kinesis Firehose, which is fully managed service, which takes your streaming data from whatever data source it is, and it either does some really small transformations on it with a Lambda, and after which it will then persist it to a data store, data warehouse, or data lake, whatever you want to, whatever suits your business requirement. In this example, we got S3, Redshift, Elasticsearch, Splunk, but there's many more that you can persist it to automatically, which is what Firehose will do for you. And the third one is if you have video content that you want to stream from your cameras, from on-premise cameras, or even recorded video, it lets you securely, broadcast that to the AWS's platform, ingest it, and then you can securely take that video footage and also perform some machine learning, further analytics, and again for whatever your business requirement is. Do you have any thoughts on those?
It's pretty confusing, all that.
Yeah.
Yeah, it's pretty confusing. I mean, it's hard to kind of sort of see the differences between them in some cases, but do you have a demo or anything?
We're going to go through a sample application later on, which uses all three of these. I guess not all three. Kinesis Video, we're probably not going to touch on today because it's more for advanced use cases, but we'll be touching on Kinesis data streams and Kinesis Firehose. So
I've got a small demo that I thought might be useful to help explain how some of these things work. Do you mind if I run through it?
Go ahead. Shoot.
Sure. Okay. So got my Kinesis Firehose. I thought we could do a little demo with that. Now, one of the things that people use Kinesis Firehose for is putting data in one end and just landing it somewhere, whether it's something like, you gave some examples there of Redshift, Elasticsearch, and Splunk. So I've got myself a little S3 bucket here. So I thought we could run through a little demo. So I'm just going to move my camera a little bit. And I'm getting my assistant here to hold my Kinesis Firehose. Would you mind holding that just for a second?
Klaus.
Absolutely. So we're going to start putting our data in one end of the Kinesis Firehose. And that's what it does. It just carries it for one end of the pipeline to the other. Now, where it gets really interesting is when you create a Kinesis Firehose, Kinesis Analytics data pipeline. Wow, I should have taken some sharper tools. All right. So what we're going to do here, we've still got our Kinesis. We're going to imagine a data stream of, whatever's we're trying to do some things within our business and understand in real time. We're just going to kind of do a bit of prep work here. If I can just thread this through. Sorry, you know what they say about demos, never do demos with animals or children, but no one said anything about retic components.
Retic.
Okay, so this is taking a bit longer than I expected.
Are we streaming cereal into that bowl?
Yes. No, it was actually M&Ms. So Marcelo, I'm going to ask for your help here. What I want you to do is to tell me the color that you see as it goes past you. So hopefully you can see this is
green, red.
Kinesis Analytics.
Okay,
so I want you to call out the colors as they change.
Yep. Red.
Slowly.
White. Green. Purple, black, white. Purple, green, red, edge, and orange. Go. Yeah. Did I pass?
It's our simple demo. Absolutely.
So that bit in the middle, that was the analytics being in action, right? We've just experienced or witnessed analytics in its true form, manifested in real life. It's something tangible that we can see and feel.
Absolutely. A small little window of the streaming application in progress.
Oh, that's awesome. That's awesome.
Yeah.
So
sorry, carry on.
The Firehose then aspect part of that was it actually persisted it to the cereal bowl, then, right? That was its final destination, the cereal bowl. So the life of that, so the data being streamed S3, okay. So the M&M started from Hamish's hand, went into the fire hose,
Yep.
and the Kinesis fire hose then automatically persisted it into the S3 bucket.
Absolutely
So,
spot on.
but a Kinesis data stream wouldn't have done that. It would have just gone out the other side, right?
That's right.
So you just continue
different options, don't you?
Yeah. Okay. So that's I guess everyone, that's the main difference between Kinesis data streams and Kinesis Firehose. Kinesis Firehose will manage the stream for you and persist it into an S3 serial bowl. Or if you just use a normal Kinesis data stream, it'll just keep pushing new data to the endpoint of the stream defining the AWS and be continuously overriding itself.
That's right.
Cool bananas. Oh, cool fire hose. Cool hose.
I like it.
All right, next is backwards. See, I'm streaming the wrong way. So on AWS, we have the product which we can do analytics with on streaming data. It's called Kinesis Analytics. So it's the process of streaming data near real time from a Kinesis data stream as the input source. And obviously that can be anything from IoT data, sensor data, live streaming data from applications like the stock exchange or logs. So the configuration point there would be you have to write a producer to capture that data, maybe massage it into a JSON format, and then output that to a Kinesis data stream defined in AWS. And it's at that point, the Kinesis Analytics will capture that as a source and perform your data processing or transformation in near real time. So the options that we have in Kinesis Analytics to do that are with Apache Flink data processing, mainly with Java or Scala. Yes, I can hear from here, everyone's cringing. Why is Java or Scala? It tends to be the preferred language, performant language used in a lot of data processing environments, especially in the Apache ecosystem and the big data. But I guess an option
GCP as well, don't you, with Apache Beam?
That's right, exactly. Yeah, in GCP with Apache Beam, yeah, you got the preferred language is Java. So yeah, you're right. But for those who don't like Java, is there an option for that can help ease the pain of writing or learning Java?
Absolutely. You know, that's one of the things that's been great about developments in that ecosystem in the last few years has been the emergence of other languages like Kotlin that make Java a lot less Java-like to work with. And it's, you know, in the same way that a lot of people favor things like TypeScript over JavaScript. It gives you that kind of strong typing and terseness in your implementation that makes it much nicer to work with.
Yeah, I had a quick play with it before. It's actually pretty cool. Yeah, it's only won me over. So the other option you have is, SQL. So running SQL queries on your data in flight to get the analytics or aggregations that you want from your data. And so it allows you to filter, aggregate, transform any streaming data. So that's the core part of the processing that you get with Kinesis Analytics. And once it's processed it, it'll output it to a sync of some sort. So the output options we have at the moment are, I guess, from the cloud platform point of view, we got Kinesis Firehose or Kinesis Data Streams. So, so Paul, what was the Kinesis Firehose again?
So it's a destination, or they call it a delivery stream. Yeah. So basically you shove stuff in and it helps you sync it somewhere.
So if we output our process data into a Kinesis Firehose, we shouldn't have to worry about configuring anything.
Saving it anywhere. Yeah. Absolutely.
Nice. And what if we...
That's a good way.
Yep.
A good way that people use Kinesis applications is to actually have multiple outputs. So for example, as part of their stream processing, they might write to a processed stream. So something where they maybe add their business logic based on the window of data.
Yep.
And they also write it out to something like a Firehose delivery stream so they can capture the original data as well. So it's pretty versatile, you could say.
Very nice. And so once that's done, we can, the data is persisted, we can then visualize it, perform some operational insights on it. Or if you have a dashboard, a real-time dashboard, and you'll be able to get insight into your business or into your data, insight that you're processing in real time, or near real time. So as the data is being produced and streamed and analyzed and processed, you'll see it within seconds or minutes, depending on how you've configured your streaming and how you're capturing the data. It's a pretty cool workflow, pretty simple, and it's all serverless again. Nothing to manage in terms of infrastructure, server infrastructure. And it scales up and down very easily. But here's a tip for you. Here's a fact. Do you know what? Hey Paul. So do you know what runs under the hood for Apache Flink and this whole data processing framework for Kinesis Analytics? And what allows it to scale up and down?
It's funny you should say that. Klaus is here with me, and he was saying that it's Kubernetes, some kind of cloud infrastructure, container scaling magic, something like that. Is that right?
Kubernetes. Yeah, that was the old version. So I think they now upgraded. AWS adopted the newer version called Kubernetes. So it's the cloud native platform to run a lot of applications that need to scale and make it more resilient. So so there you go. Under the hood of this service on AWS, they're running a Kubernetes cluster, which is on their EKS platform.
It's lucky you don't have to manage that. I heard it was a real pain to do that.
Well, I know some people who really know their shit when it comes to Kubernetes. And there's actually a certified service provider in town in Perth now, the first one.
Yeah.
I think they should be able to handle it.
There's probably not many people that have that kind of qualification, really.
No, it's not easy to. But yeah, we can make it easier for you. So
yeah, that's really interesting. Sounds like something for another webinar.
Yeah. So we persisted that data now to the an S3 bucket or Redshift, and so here's a bit of a visualization on the workflow of a processing streaming data. So it's stateful stream processing. So what that means, it actually, as data is coming in, it will save a subset of that data in the application as it's running. So you'll have historic data as well as current data. So with that, you get to create a nice, aggregation kind of framework. So you can apply maybe, so you want to know what was the maximum, I guess in the application that we're going to talk about. So if we're trading a stock and you want to know what that stock was traded at in the last, say, 60 seconds, what the highest price was, you can create a time window of 1 minute and perform an aggregation of a maximum operator from Flink to tell you during that 1 minute. So AWS traded at a maximum at a highest point of $1, for example. So, and then it would go to the next minute and give you maybe the next minute after that, next max was maybe 60 cents. Oh shit, something happened to AWS, So that's where the stateful stream processing comes in handy with. And Flink, Apache Flink out of the box comes with a lot of operators pre-built, pre-written for you, so you could use, which makes things a lot easier. It scales very easily up and down, very fault tolerant, having checkpoints and snapshots of your running application. And again, it's Java or Scala in this case. So if we just walk through the process workflow here, so you've got your streaming data source on the left, which is your Kinesis data stream. Where it says your code, that's where your Kinesis Analytics application is running and deployed to. And so that'll be ingesting that stream, the data stream, performing your analytics, your business logic, and then the arrow that's going down is where it's storing the state, temporary state of whatever you've defined in your parameters. And once it's done processing the data for that time window that you specified, it will output it to a sync, which could be another Kinesis data stream or Kinesis Firehose. Does that make sense to you, Paul?
Yeah, it does. I mean, I suppose the other aspect of it is how you kind of deploy it and manage it. What's your experience with that?
In deploying and managing it, like CI/CD,
Yeah.
you mean?
Well, how do you package it, or how do you put it together? How do you actually get it deployed to the service?
Quite easily,
Fairly
actually.
straightforward.
Yeah. So if we keep to the Java, I guess, as a language in what, how we write our code, our application for the analytics part. So we'd first actually create our data streams through CloudFormation. We can also define a Kinesis analytics application through CloudFormation. So you put all that as infrastructure as code, and you'd have your application source of Java, in this case in a GitHub repo. You've got it there. Once you're ready to, you're happy with it. Okay. You push your changes up to the GitHub repo, and then we put it through a code build step, and code build would actually then build the application, and the jar artifact that it produces, it'll put into a jar, into an S3 bucket, but it'll also name the application name. It'll append the commit hash of the push that was committed to, and then with that, it'll create a new application name and deploy it to the bucket which Kinesis Analytics is monitoring. So, and it'll activate it from there, and then you're ready to go, really. So when you have a new version of it, if you the new application will be detected by the new name of the artifact that you deploy, which will be the application name and the commit hash of the version you just committed. So that's how you're going to keep track of what version is running as well.
So you don't have to stop and stream the Kinesis application to deploy it. You just need to update the bucket with the artifact, and it does all the work for you. Exactly.
So it's
pretty cool.
Kinesis Analytics service will wait for the time window to stop processing, and it'll cleanly, this all happens for you. It'll stop, and then it'll activate the new application, the new version of it, and start applying that new code to the next streaming session. So yeah, it's pretty seamless. But that's how it works. So, and next, what are the benefits? I guess we touched on some of this already. So there's no service to manage, scales automatically, pay only for what you use, respond to incoming streaming data near real time, stateful processing, and yeah, Kubernetes under the hood. So you'll be able to scale and perform quite reliably. So they're the main benefits of Kinesis, and as the times that we have used it and deployed it for customers, it's been quite easy and quick to get going. So there's always that, I guess, the thought that people have, oh man, streaming data is hard. You've got to have all this infrastructure in place to let it scale and balance and stay stable. But I mean, once we had this up and running as for a sample application, I looked at it and goes, geez, that was easy and quick, and easier than I thought it was. So
that's it. Yeah. Not worrying about Zookeeper falling over or how many nodes you've got running.
So you mentioned Kafka before. So have you worked with Kafka? And how easy was that? Yeah. And how easy was that?
Well, when I set it up, I use Docker containers. So much of the hard work's done, but you're responsible for keeping it running and for the communication and managing the resilience of one of the container stops, that kind of thing. And there's obviously other services that can help you manage that as well, but it depends on your use case. Sometimes people will choose platforms like Kafka because they have some pretty intensive raw performance requirements, and Kinesis can handle high performance as well, and high raw throughput, but each use case is different, but it's definitely worth having a look at Kinesis data analytics applications.
Cool. So I guess in your case, you would need more people who were more experienced with infrastructure and Docker containers and that kind of stuff, right? So Kinesis Analytics in AWS, you don't need to know any of that really. Just your
you just need to have some data.
Yep. Yep. With your Firehose and your S3s and M&Ms and your cereal bowl, you can't go wrong.
Absolutely. All set.
Right, so here's an architecture diagram of a sample, I guess a good way to structure your streaming data with analytics. So we've touched on it. So you've got your data source here, producing data, which is essentially be your Kinesis producer. So you can either write your own libraries, like with KPL, Kinesis producer library to generate the data into Kinesis data stream, which is in AWS here. And then from there, you got your Kinesis analytics, output. In this case, we're outputting to a Kinesis data stream and then to a Kinesis Firehose. Why do you reckon we do that, Paul?
Well, the good thing about channeling your output to another Kinesis data stream is that you can have multiple consumers. So for example, it'd be great for you to do what you're doing right now, which is to write that data to a destination, for example, so you can have a data lake or channel that data to a data lake. You may have other applications that want to leverage that data. So by using a Kinesis stream, you've got the option to expand that, and you're still paying as you go. So it's a good value option.
Cool. So what we, I guess we'll just quickly, to finish off, we'll wrap up with an example that I recently blogged about and published the example code and reference in a mechanical blog website. So I guess just to talk a bit about that and how that was done as a basic streaming application with some basic analytics. So what we were doing then, we were streaming a company's performance on the stock exchange. So the volume, the price over a period of time. So what we wanted to know, what this investor wanted to know was, out of these 5 cloud platforms, so you had AWS, Google, Azure, Alibaba, and Oracle, which one of those, and how are they performing in trading in real time? So he didn't want to wait to the end of the day, end of the trading session to then go, oh, I should have bought or I should have sold, for example. So that's the problem we're solving in this example. So what we're doing then, we're streaming the data from those 3, the ticker ID, so from those 3 businesses. So they're streaming their price on the stock exchange every second. So
that sounds like something that Klaus would do to monitor the response to his tweets for those companies that he tweets about.
Yes, that's one thing is, that is quite good at, is making the most of his data and just getting some value out of it. So, an insight into what he's tweeting about and how much engagement is generating, so an interest. So yeah, the Klaus is quite good at that. He's probably a good example, again, a good thought leader in that space. So we should take a note out of his book and keep that in mind. So yeah, as we're streaming this the stock exchange out of these 5 companies that we have, so they're all going into this just the one Kinesis data stream. So you have AWS, Google, and Azure, Alibaba, and Oracle. So they're all at the same time transmitting the data, which will have the event time, the ticker ID, and the price. At that point in time, will be continuously streaming into this Kinesis data stream. So what we want to know is, what this investor wants to know every minute, so every 60 seconds, what was the highest volume or highest price that these 5 cloud platforms traded at. So in the Apache Flink configuration, we configured a sliding window. So a sliding window where we define how much time we want to capture data in that I guess space of time. So for example, in this time we want to capture 1 minute of data, and then once we get that 1 minute of data, we're going to apply our business logic, our application that we just wrote in Java and Flink. Okay, it's keyed or partitioned by the ticker ID. So meaning for all the AWS ones, it's going to get during that 60 seconds, it's going to get the maximum price that it traded for that 1 minute. And then it's going to output also the one for AWS, the one for Google, the one for Alibaba, and one for Oracle. So the output of that processed window of 60 seconds will be just the maximum price that those company's traded at for that 1 minute and output it to the Kinesis data stream or a Kinesis fire hose, and which would then persist to an Elasticsearch dash or a dashboard. That's gives you a visual representation of your data in near real time. So that's essentially the process of what we're doing there, and we actually achieved that quite easily with this Kinesis Analytics, and they were able to get the data that they wanted and insight into whether to buy or sell quite quickly on the cloud without having to build any infrastructure locally.
That's pretty cool.
You get ideas.
Did you say Oracle Cloud?
Yeah, it's awesome. Yeah.
Is that a real thing?
I'm not sure actually. I've heard of it. It's like the unicorn of clouds, I guess. But yeah, yeah. Maybe Klaus has a good experience with Oracle Cloud. Yeah.
Nice work, Marcelo. It's pretty interesting.
So yeah, there we have it. Streaming 101. You can do it. Anyone can do it. Yeah, so that's pretty much all you need to know, or I guess to get started. What are you going to write about, Paul? What are you going to start streaming? How many M&Ms? That's an idea.
Absolutely.
So, would you be interested in knowing?
M&Ms to my kids' behavior.
That's not a bad idea, actually. But I know that you can put it through a computer vision process where you want to know how many yellow M&Ms and how many blue M&Ms are in a packet, streaming through that fire hose, right?
Yeah.
So you can get the Kinesis Analytics to do that for you. Yeah. All right, Paul. What's next for us on Data Month?
Oh, that's a good question. I think we might have some more blog posts. One about centralized log management. There, I've said it. I'm committed now. And yeah, there's more to come later in the month. Maybe looking at how to integrate ML applications with Snowflake, as an example.
Sounds interesting.
Yeah, I'll believe that when I see it.
Exciting times. So yeah, stay tuned for Mechanical Rockstar Data Month series of blogs, videos, and discussions. If you want to help participate in any of these, just reach out and can help join in the Data Month fun. All right, and that's
see you next time.
That's a wrap. Cut. No, wait, I've got to stop recording. Actually, wait.
There you go.
All right, we're going to finish soon. All right, wait. Stop sharing.
Fix it in the mix.